Good morning. This is Professor Grenfell's Math 12 Statistics class, and today we are still in Chapter 9, with opening up Chapter 9, Section 4, on testing the difference between two proportions. And this is going to be basically just the same as all of the other hypothesis tests that we've done. This is a z-test, and by now you should be familiar with that. You should know that that means we're going to be utilizing our z-distribution to find our critical values. And in fact, for all of the common values of alpha, we already know those corresponding z-values. So this one is nice. Here are the important formulas. So, wow, boom, here's the set of important formulas. Z, the test statistic, is computed by taking the difference in the sample proportion. So that's P1 hat minus P2 hat minus the hypothesized difference in the population proportions. Remember, we don't know P subscript 1 or P subscript 2. We just know the information from our sample, the hat ones. This right here is usually equal to 0 because that's usually what we're testing with our null hypothesis. We're saying it's equal to 0. But this does give us the capacity to say that they differ by some other margin greater than 0. What else do we have here? Oh, yeah, more stuff. This is all divided by the square root of P bar times Q bar times the whole thing, 1 over n subscript 1 plus 1 over n subscript 2. So that's a whole lot of stuff. The most important thing to do here is to make sure that we can keep track of all of the different P's and Q's. Literally, we have the ones with the hat over here, such as P1 hat and P2 hat. These are the sample proportions. So to compute P1 hat, we would take x1 divided by n subscript 1. And that would be the number of successes in our sample from sample 1 divided by the total number in the sample from sample 1. And same thing here, we compute the sample proportion for the second sample, for the second population. And then we don't use either of those except in this part of computing the statistic. We, instead of taking P1 or P2, remember, we don't know these. These are unknown. So instead, we get an estimate for this. The P bar is a weighted average. So basically, you just have to remember, add up your total successes from both samples, add up the total number from both samples, and compute that proportion. Then Q bar, of course, is just going to be 1 minus P bar. Right, so that's kind of a lot. But thankfully, at least it's not as much as last section. So at least there's that. All right, let's go into an example and put this together. Okay, so let's go ahead and take a look at this problem. This is example 9-9, and we're looking at page 521 in our textbook. I'll read this problem. The theme is on vaccination rates in nursing homes. And it says, in the nursing home study mentioned in the chapter opening Statistics Today, the researchers found that 12 out of 34 randomly selected small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 randomly selected large nursing homes had a vaccination rate of less than 80%. At alpha equals 0.05, test the claim that there is no difference in the proportions of the small and large nursing homes with a resident vaccination rate of less than 80%. So let's pause for a second. You can see here, the first thing that I'm going to do is I'm going to decide which which population is which. I'm going to designate one of these as population 1 and the other as population 2. And then for each of these different populations, I'll look at the information given for their respective samples. So I've designated, let's see, it's just arbitrarily said the small nursing homes, that's going to be population 1. The large nursing homes, that will be population 2. It says 12 out of 34 randomly selected small nursing homes have this vaccination rate of less than 80%, and then 17 out of 24 randomly selected nursing homes, large nursing homes, have this low vaccination rate. Notice the 80%, that figure never enters in here. That's just the demographic, or that's just the description that they're using, right? So our successes are finding a nursing home that has this low vaccination rate, and then the N, that's just the sample size. So here the sample proportion is 12 out of 34. And we can get a calculator to see what that reduces down to. And then similarly here, this one is 17 out of 24. And we'll let the calculator do its job on both of those. Okay, so we got 0.35 for the first sample proportion and 0.71 for the second sample proportion. So already it's looking like there is some kind of difference, but remember, we have to test it. We have to test it with the hypothesis test. So the next thing that we're going to have to do, as you can see right here, we have to we have to calculate P bar. That's the weighted average combination of these two proportions, these two sample proportions. So what is this going to be? This is going to be 12 for the first number of nursing homes plus 17, all divided by, here we had a total of 34, and here we have 24. So we'll be adding those together, and this works out as 29 over a total of 58. And this one is actually exactly equal to 0.5. So that means that Q bar is 1 minus P bar, so that is also going to be 0.5. So that's actually pretty nice. And now that we have everything all calculated, yeah, we can go ahead and begin the hypothesis test. Step 1, state the hypotheses and identify the claim. All right, so here I'm going to say it like this: P1 minus P2 is just 0. There's no difference. Another way to say that is P1 is equal to P2. And then the alternative, well, we're just testing to see if there is a difference, and so we're just going to say a two-tailed test. Use a two-tailed test, so P1 minus P2 is not equal to 0. All right, step 2, sketch the critical region and find our critical values. So here, I think alpha is 0.05. So for a two-tailed test, that means this area on the left is 0.025. And this area on the right, similarly, is 0.025. And this is one of the ones where, well, you know what, I'm going to pause and go and look it up. But this is the one, well, this is one of them that we don't have to. Since we're using the Z distribution, we don't have degrees of freedom that change up on us. And so whenever they give us alpha equals 0.05, we have plus or minus 1.96 as our values. And yes, I did check those, and yes, they are correct. Step 3, we're going to compute the test value. Okay, so we have this long-winded formula, P1 hat minus P2 hat minus the whole quantity, P1 minus P2, all divided by the square root of the whole entire thing, P bar times Q bar times 1 over n subscript 1 plus 1 over n subscript 2. Wow, that's a whole lot. That's why I write these things ahead of time when the screen is paused. All right, and we're going to just simply plug in all of the values that we already had gone ahead and solved for here. So we have 0.35. Oh, sorry, I'm going to run out of room here. I'm going to pause. Right, so there it is. Had to just kind of clean it up a little bit so it would all fit in there. And we got negative 2.70. And so notice here, this is where? Oh, it's way over here, well within the rejection region. So step 4, make the decision, reject the null hypothesis. H subscript 0, reject that. And then 5, summarize the results. So in 5, I have written here, the evidence suggests there is a difference in the proportions of small nursing homes and large nursing homes with a resident vaccination rate of less than 80%. Now, notice, it looks as if the large nursing homes have a higher proportion, and we can certainly go ahead and test that claim. We could even put in, you know, a margin of error. We could say this, the large nursing homes have at least 10 percentage points higher vaccination rate with than the lower, the smaller nursing homes. But we would have to state that as a separate test, and then perform a single-tailed test to test that claim. All we've done here is we've said, you know, look, it looks as if there is some difference. It will take further testing to analyze and see exactly what that difference is. And we can address that in different examples.